Hi, I'm Printed for Fun. I have 3D scanned my new camera. It's a DJI Action 6, and sadly it didn't come with a protective cage as the earlier versions. So I just scanned it and will create a cage from it. In this video I will mainly focus on the post-processing steps within Exstar Hub to show you how the alignment is working and some other very useful tools. You can see I have two scans. I have side 1 and side 2. Let's first focus on side 1. Here you can see I created a cutting plane while scanning, so there isn't much data from the geometry. It's different with side 2, that I haven't removed the scanning geometries. So let's see, for scan 1, I guess we don't need to do any further preparation. And you also have to know, this point cloud you're now seeing is directly created when finishing the scan, so there is no additional fusion step. For side 2, I will hide side 1. We will still need to remove the marker geometries. To remove the floating data, like the first tool you could be using, or the first tool you may know, is simply selecting the data manually. But first let's switch into the orthogonal view. So this makes it a bit easier to select the data. So if I look from top and now switch back to perspective view, you see it gets distorted due to perspective. To select data, you select one of the selection tools, like rectangular selection, polygon, lasso, line, or paintbrush. And to actually start the selection process, you have to press the shift button, and then for the polygon selection, you can just select the data like this and delete the selected data. So this is the default version, I would say. Another option you have is selecting only the data you want to keep and then inverting the selection. This would also work, but I would like to show you a way more efficient and easy approach to this. I just select the paintbrush tool and brush on the camera body. Now I use the connected domain, and as you see, it selected only the camera and not these free floating parts, so I can invert and delete the data. So this is the most efficient version, I would say. In the next step, we need to align the two scans. This can be done in the alignment window. So for you to see, it's here in Projects Alignment, and I will do automatic feature alignment. You also could do manual alignment, but I guess it isn't needed since there is sufficient overlap between the scans. There is also the option for marker alignment, but when we go back and look at the scan, the markers aren't on the scan object itself, they are on the turntable I scanned the part on. So they are the same for both scans, so it won't align successfully since it would try to align the turntable I placed on and not the actual camera I scanned. So we can just use the alignment. Fixed window will be 1. No, I will actually use fixed window 2, so I already have a gist of alignment. And then you have to select the floated window, it's side 2, and I can hit apply. And as we can see in the bottom window, it aligned perfectly. So there is no need to do manual alignment again. So I just can exit, and what's quite nice, you still have the separate scans or separate files, but they are aligned to each other. So you can hide one of them or edit the other one. Now, after we have aligned these scans, I can also hide the markers. I guess it's even the default option if you don't unfold it. So, okay, it's not. Okay, so next step is now we have a point cloud, and now I want to create my mesh. This is just the mesh model function right at the side. So you see it, it's in the right bottom corner. And generally speaking, I'm most of the time quite happy with using the recommended settings. You'll just try them now out. And for like 90 to 95% of my scans, I am fine with the recommended settings. So there isn't like real need to go higher in the setting. Let's see. Actually, it's moved a bit too much for my opinion. We're getting 400,000. I will choose no filter at all. So let's see how the result is looking. Okay, this makes it a bit sharp, but okay, let's retry the filter. The resolution of the scan is chosen quite low. The reason for this was I used my notebook with only 16 gigabytes of RAM for scanning. Now I'm working on a workstation with 64 gigabytes, and you have to be told it's also like in the official manufacturer specs, 16 gigabytes is way too few for the Rocket. So near scans are working okay-ish while scanning, but the point cloud generation generally fails at the 16 gigabytes of RAM, and laser scans for like a resolution below 0.3 millimeters or 0.4 millimeters fill up the RAM after maybe 30 to 40 seconds. So I then have to like stop the scan and maybe perform a second scan. But I guess for only designing a case, this is usable. I still see where the hatches are, where the connection points are, but I may redo the scan in a higher resolution if you think it would be interesting. So now you have the mesh data. It looks quite fine. We could also optimize the mesh, maybe like, let's try it out. Actually, I haven't tried this optimization feature yet. I guess it's more like, let's see what it does. Okay, it reduces like the triangle count dynamically, but I don't need it. What's actually more interesting for me is alignment of the scan. That's quite nice that the Exstar software actually has a proper alignment functionality within the software. In the post-processing, you don't find alignment. You have to like keep in mind of this. You find the alignment function under measurement, since it like uses the measurements to align. This may be a bit contra-intuitive, but that's how it works. It's like here on the side you have the create feature, you have align, you have measurement tools, and you have multi-view. Like measurement tools are quite nice. You can directly determine the volume of the part, but since I have the holes down right here, because I didn't choose hole filling or didn't choose watertight model while meshing. If I had chosen watertight, it would work. You also can calculate a surface area by here. I will do a polygonal selection, and I can see it's like 5,000 square millimeters. And I guess I can also like save it. I can save the measurement values to a TXT file or CSV. That's quite nifty. Nice. Like I would say recording, maybe one additional improvement they could be doing. I don't know if like the more professional versions of this can have this, like it doesn't only record a measurement to a TXT file, but also records an image of the selection by the side of it. So you have like direct reference. With the current solution, it's more like I still need to record the scanning or the measurement process. Same works for like measuring distances. 1, 2. I also see like the extension in the axis, but since I'm currently not aligned, they don't mean a lot. So let's do the alignment first. There are multiple alignment versions. You can do like precise alignment by selecting or like by manually moving the part, but this is, generally speaking, I don't use it because I either want to perform a quick align, which is very useful. So you just like, if you read it, these adjust the object to a suitable front view and click the alignment. So basically, I will try to align the part in a frontal view, click on align, and now it is aligned. So that's very nice for like if I plan on using it in quick surface later. I also already have my initial alignment, and when loading the scan in, it isn't like completely off origin. You also can move the coordinate system to the bottom of the part. That's very nice if I do like Sketchfab uploads or like for short client demonstrations. So if I have like these online viewers, it is directly aligned, and the shading and the rendering is working fine. So let's see. Okay, I'm still a bit angled. So this is where the point where I would use the 3-to-1 alignment. But to use the 3-to-1 alignment, I first have to create features. Or like, I have to, it's called create features here in the software, so it's quite nice. So what will I use for the alignment? I will try to use three planes. I will select plane, I will select best fit. So let's first try to use the brush. I will brush like a plane selection on the bottom and will create my plane. Did I have, I chose select through, so select through is like, it selects on both sides of the mesh. So if I go down there, so no one that created a plane like this, so we have to use the select visible. So I will delete this plane in the overview. So now second chase, okay, this looks fine. So I will create another plane here in the front and a third plane. Let's do it here on the side. I guess this is good planar. So guess it's not fully right since I got the writing, but it will suffice. So now I can do the 3-to-1 alignment. So I can select plane 2. Okay. I cannot use like directly 3 planes. I need to use plane, line, point. So we'll go back to features. So our line will be, let's try it. Point to point, plane, plane intersection. Yeah, we can actually do plane, plane intersection. Plane, 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 plane. Great. Okay, that's nice. And now we can also, now we need a point, and the point will be somewhere here in the front, maybe. Line plane intersection. This sure sounds, is it possible? No, it is not possible. So I will maybe try plane, okay. So let's try if this will work. I haven't used this type of alignment yet. So we will need to see if it is okay. It doesn't make sense since the line 1 is like the normal vector of the plane 2. So I will go back there, and I guess I will create another line from this and this plane. And now we should be able to do the alignment. I'll need plane 2. Yeah, okay, it worked, great. So let's look at the side view. So we have like this quick view, and I would say it looks quite nice. Also top view, side view. So the alignment is a bit different than in quick surface. In quick surface you can like directly reference 3 planes. Here you need like plane, line, point, and the line cannot be like the normal vector of the plane. But yeah, so the next step is exporting the scan. So I will use DJI Action 6, and I will use the PLY file format. I just prefer PLY since it is a bit more efficient in storing large scan data. And you actually have to you have to save the mesh now, because if I go back to the scan, you see the mesh data will be deleted. So keep this in mind. If you have any additional questions about like functionality of the software, I'm happy to like create an additional video if you want to. Maybe about like the scan settings itself, if they are a bit unclear, but this was mainly the post-processing step within Exstar Hub.